Hi, in this video we are going to discuss one of the dimensional reduction technique, that is the tSNE. In previous video we have discussed about the PCA technique, but in the PCA we have some disadvantages are there. To avoid those problems we are going to use the tSNE. tSNE is like a T-distribution stochastic neighborhood embedding. This is a PCA is going to preserve the global structure of the data, and tSNE is preserve the local structure of the data. Okay. For example, how it preserve the local structure of the data, that we will see. Here we are going to use the neighborhood approach and the embedding. Because of these two things we are going to preserve the local structure of the data. For suppose x is the data point in the higher dimensional, it is a dimensional d, let's consider d, and for this point we are going to create a point x dash, okay, x dash in the d dash dimensional, d dash is less than d. Okay, it's like a embedding, convert the higher dimensional data point to the lower dimensional. That's why we call as embedding. And our neighborhood means we are going to preserve the distance of the neighbors. We are not going to preserve the points are very far in the higher dimension, in the d dimensional. We are not going to preserve that distance. We are only going to preserve the distance between the neighbors only. Let's see some intuition about the tSNE to get more understand how it's work. Let us consider these are the data points in higher dimensional D. Let's consider dimensional of D. We need to convert this one into D dash. Here D dash is less than D. Now we can see here this is the neighbor points and this can form a cluster. These are the neighbor points. It's like a cluster, and these are all our neighbor points, and this is like a cluster, and this is also a cluster. These are the neighboring points. This is a single point. These are all the points are going to for all the points. In the tSNE what we are discussed, we are going to preserve the distance neighbors, and we are not going to preserve the distance of the point if it is far, that means outside the cluster. Here when we convert the data into lower dimensional, for example, let's consider this point x1, this different color. Let's consider this point as x1 and x2, x3, and similarly these points like x10, x2, x12, and this one is x15, x16, this is x20. Data we have points x1, x2, x20 points are there in the d dimensional. By applying tSNE we are convert this 2 into lower dimensional, x1 dash, x2 dash. For every point we are going to create a new point in the lower dimensional, x3 dash, x20 dash. The dimensionality is going to be d dash, d dash is going to be less than d. Now let's consider d is the it is different color. Let's consider ds is the distance finding between these 2 points, the x1 and x2. In the previously the distance is same as ds x1 bar and x2 bar, and similarly ds of x1 x3 is equal to ds of x1 x3 dash. Similarly distance of x2 x3 is same as ds of x2 dash x3 dash. That means we and then distance between x1 and x10 is not same as distance between x1 and x10, x1 dash, x10 dash. Sorry. And similarly, distance between the x2 and x10 is not same as distance between x2 dash and x10 dash. And the distance between the x10 x12 is equal to the distance between the x10 dash and x12 dash. By this way, what we can tell, the distance between the x1 and x2 is same as x1 x2. By applying tSNE, we are going to preserve the distance between these points which are there in the cluster, and we are not going to preserve the distance between the points which are outside the cluster. For suppose we are going to preserve the distance between these points after applying tSNE also, but we are not going to preserve the distance between these points to these points. Okay. Similarly for these points, okay, but we are preserve the distance between the internal points, that is the neighbor points. This is all about the tSNE. And tSNE also some problems are there. There is a crowning problem is there in the tSNE also. Let's see that one also. Let us consider these are the data points x1, x2, x3, x4. Let's consider, and the distance between these data points is like a d is same. Now it is in the 2-dimensional. We need to convert this one into 1D dimensional by using the tSNE. Now in the 1D dimensional we have only single line here, and the data points that we will get here like x1, here x2, and here x3, and here x4. Here the thing we can observe, the distance between the x1 and x2 is same before and after the tSNE, it's a d. And the distance between x2 and x3 is also same before and after applying tSNE. And the distance between the x1 and x4 is also d before and after tSNE. But the distance between the x4 and x3 is not same before and after. Here the distance is going to be 3d, but here only d. This is the one problem we are going to face in the tSNE.